Data, the lifeblood of modern businesses, fuels decisions, drives operations, and empowers innovation. In the realm of relational databases, Oracle stands tall as a robust and reliable system for managing this critical asset. At the heart of Oracle's power lies its unwavering commitment to data integrity, ensuring that the information stored within its databases is accurate, consistent, and reliable. Constraints, the unsung heroes of data integrity, play a pivotal role in upholding these principles. This deep dive into Oracle constraints will unravel their significance, explore their diverse types, and illuminate their practical applications. Imagine a vast library meticulously organized, with each book meticulously categorized and shelved. Constraints in Oracle database serve as the librarians, diligently enforcing rules that maintain order and prevent chaos. They ensure that every piece of data adheres to predefined standards, preventing inconsistencies and errors. Just as a library catalog ensures that no two books share the same identification number, constraints in Oracle guarantee that data remains unique, consistent, and reliable. Whether you're a seasoned database administrator or a budding developer, understanding constraints is paramount to harnessing the full potential of Oracle database. This exploration will equip you with the knowledge to implement, manage, and leverage constraints effectively, fortifying your database against data corruption and upholding the sanctity of your information assets. Prepare to delve into the intricate world of Oracle constraints, where precision and reliability reign supreme. From the fundamental primary key constraints that underpin relational databases to the versatile check constraints that enforce complex business rules, this journey will illuminate the multifaceted world of data integrity in Oracle. By mastering these concepts, you'll gain the tools to build robust, reliable, and trustworthy databases that serve as the bedrock of your organization's success. Let's embark on this enlightening exploration of Oracle constraints, where data integrity takes center stage. In the digital age, data is king, driving decisions, shaping strategies, and propelling businesses forward. Data integrity, the cornerstone of reliable information systems, ensures that this valuable asset remains accurate, consistent, and trustworthy. Within the realm of Oracle database, data integrity reigns supreme, safeguarding the sanctity of information and underpinning the reliability of business operations. From financial transactions to customer records, maintaining data integrity is paramount to organizational success. Imagine a world where financial records are riddled with errors, customer orders are processed with incorrect details, or inventory management systems reflect phantom stock. The consequences of compromised data integrity can be catastrophic, leading to financial losses, operational disruptions, and irreparable damage to an organization's reputation. Oracle Database, renowned for its robust architecture and unwavering commitment to data integrity, provides a secure and reliable platform for managing critical information assets. Constraints, the guardians of data integrity, play a pivotal role in upholding these principles within Oracle Database. They act as sentinels, preventing invalid data from infiltrating the system and ensuring that existing data adheres to predefined rules. These rules, meticulously defined and enforced by constraints, dictate the permissible values, relationships, and formats within a database, ensuring that data remains consistent, accurate, and reliable. From the fundamental primary key constraints that uniquely identify each record to the intricate check constraints that enforce complex business rules, Oracle offers a comprehensive suite of tools to maintain data integrity. By understanding and implementing these constraints effectively, organizations can fortify their databases against data corruption, ensuring that their information assets remain trustworthy and reliable. In the subsequent sections, we'll delve deeper into the specific types of constraints available in Oracle, exploring their functionalities and practical applications. At the heart of relational databases lies the concept of primary keys, the unique identifiers that distinguish one record from another. In Oracle Database, primary key constraints enforce this uniqueness, ensuring that no two rows within a table share the same primary key value. This fundamental constraint forms the bedrock of data integrity, guaranteeing that each record can be accessed, modified, and referenced with absolute certainty. Imagine a library where each book is assigned a unique identification number, enabling librarians to locate any book instantly. Primary key constraints in Oracle are not merely suggestions, they are ironclad rules, rigorously enforced by the database engine. When you define a primary key constraint on a table, Oracle guarantees that no two rows will ever share the same primary key value. Attempting to insert a duplicate value will result in an error, preventing data duplication and maintaining the integrity of the database. This unwavering enforcement ensures that the primary key truly serves as a unique identifier for each record. Consider a table storing customer information, where the customer ID serves as the primary key. The primary key constraint ensures that no two customers can have the same ID, guaranteeing that each customer record is uniquely identifiable. This uniqueness is crucial for accurate data retrieval, preventing ambiguity, and ensuring that operations such as updating customer details or processing orders are performed on the correct record. In SQL, defining a primary key constraint is straightforward. For instance, to define a primary key constraint on the customer ID column of a customer table, you would use the following SQL statement: alter table, customer add constraint, customer underscore, PK, primary key, customer underscore ID. This statement instructs Oracle to add a primary key constraint named customer underscore PK to the customer table, enforcing the uniqueness of the customer underscore ID column. Primary key constraints, the bedrock of relational databases, ensure that each record possesses a unique identifier, maintaining data integrity and enabling accurate data management. Relational databases excel at representing relationships between different entities. Foreign key constraints, the glue that binds these relationships, ensure that data across related tables remains consistent. Imagine a library where books are categorized by genre. A foreign key constraint would ensure that each book's genre reference points to a valid genre category in the genre table, preventing orphaned records and maintaining data integrity. In Oracle Database, foreign key constraints enforce referential integrity, ensuring that values in one table's column correspond to values in another table's primary key. This constraint prevents orphaned records, where a record in one table references a non-existent record in another table. For instance, in an order management system, a foreign key constraint would ensure that each order references a valid customer in the customer table, preventing orders from being associated with non-existent customers. Consider an orders table and a customer table. The orders table contains a customer underscore ID column, referencing the primary key of the customer table. A foreign key constraint on the customer underscore ID column ensures that every order is associated with a valid customer in the customer table. This constraint prevents scenarios where an order is placed for a customer that doesn't exist, maintaining the integrity of the relationship between orders and customers. To define a foreign key constraint in SQL, you would use a statement like this: alter table orders, add constraint order underscore customer underscore FK foreign key, customer underscore ID, references, customer, customer underscore ID. This statement instructs Oracle to add a foreign key constraint named order underscore customer underscore FK to the orders table, enforcing that the customer underscore ID column references the customer underscore ID primary key in the customer table. Foreign key constraints, the guardians of referential integrity, ensure that relationships between tables remain consistent and reliable. Section 5. Unique constraints, ensuring data uniqueness. While primary keys guarantee the uniqueness of a table's primary key column, unique constraints extend this concept to other columns, ensuring that no two rows share the same value in a specific column. Imagine a library where no two books can have the same title. A unique constraint would enforce this rule, preventing duplicate book titles and maintaining data integrity. In Oracle Database, unique constraints prevent data duplication in specific columns, ensuring that each value in that column is distinct. This constraint is particularly useful for columns that hold information that should be unique, such as email addresses, national identification numbers, or product codes. By enforcing uniqueness, these constraints prevent data redundancy and maintain the accuracy of critical information. Consider a table storing employee information, where the email address column should be unique. A unique constraint on this column ensures that no two employees can share the same email address, preventing accidental data duplication and ensuring that each employee can be contacted reliably through their unique email address. To define a unique constraint in SQL, you would use a statement like this: alter table employee, add constraint employee, underscore email underscore UK unique, email underscore address. This statement instructs Oracle to add a unique constraint named employee underscore email underscore UK to the employee table, enforcing the uniqueness of the email underscore address column. Unique constraints, the guardians of data distinctness, ensure that specific columns maintain unique values, preventing data redundancy and enhancing data accuracy. Section 6. Check constraints enforcing business rules. Check constraints, the most versatile of Oracle's constraint arsenal, empower you to enforce complex business rules directly within the database. Imagine a library where only books published after a certain year are allowed. A check constraint could enforce this rule, preventing the addition of books published before the specified year and maintaining data integrity. In Oracle Database, check constraints define specific criteria that data must meet before being inserted or updated in a table. These constraints allow you to implement complex validation rules, ensuring that data conforms to business requirements and preventing the entry of invalid or illogical values. From simple range checks to intricate logical expressions, check constraints provide unparalleled flexibility in data validation. Consider a table storing product information, where the price column must always be greater than 0. A check constraint on this column would ensure that no product can have a negative or 0 price, preventing illogical data entry and maintaining the consistency of product pricing information. To define a check constraint in SQL, you would use a statement like this: alter table product add constraint, product underscore price underscore CHK check, price 0. This statement instructs Oracle to add a check constraint named product underscore price underscore CHK to the product table, enforcing that the price column must always be greater than 0. Check constraints, the enforcers of business rules, provide a powerful mechanism to validate data and ensure its conformity to predefined criteria. Section 7. Adding constraints. Building a robust data model. Adding constraints to an Oracle database is akin to fortifying a castle, bolstering its defenses against data corruption and ensuring the integrity of its valuable information. Just as a castle's walls protect its inhabitants, constraints safeguard data by enforcing rules, preventing inconsistencies, and maintaining order. The process of adding constraints is straightforward, involving simple SQL statements that define the desired restrictions. To add a constraint, you use the alter table statement, specifying the constraint type, the constraint name, and the columns involved. For instance, to add a primary key constraint to a table, you would use the ADD constraint clause followed by the primary key keyword and the column name. Similarly, to add a foreign key constraint, you would use the foreign key keyword and specify the referenced table and column. Oracle's SQL syntax provides a clear and concise way to define constraints, empowering you to tailor your data model to specific requirements. Whether you're adding a simple check constraint to validate data ranges or implementing a complex foreign key constraint to maintain referential integrity, the process remains consistent and intuitive. By carefully adding constraints during the database design phase, you lay the foundation for a robust and reliable data model, ensuring that data integrity is ingrained from the outset. These constraints act as vigilant guardians, preventing data inconsistencies, enforcing business rules, and upholding the sanctity of your information assets. Section 8. Dropping constraints, flexibility and modification. While constraints are essential for maintaining data integrity, there may be times when you need to modify or remove them to accommodate evolving business requirements or database schema changes. Oracle Database provides the flexibility to drop constraints, enabling you to adapt your data model to new demands without compromising data integrity. Imagine a castle undergoing renovations, requiring the temporary removal of certain fortifications to accommodate new structures. To drop a constraint, you use the alter table statement with the drop constraint clause, specifying the constraint name. Oracle will carefully remove the constraint, ensuring that data integrity is not compromised during the process. Dropping a constraint does not delete data. It merely removes the restriction enforced by that constraint. The ability to drop constraints provides valuable flexibility, allowing you to modify your data model as needed. For instance, if a business rule changes, you can drop the corresponding check constraint and add a new one that reflects the updated rule. Similarly, if you need to restructure tables or relationships, you can temporarily drop foreign key constraints to facilitate the changes. However, caution is advised when dropping constraints, as removing essential constraints can jeopardize data integrity. Before dropping a constraint, carefully analyze its impact and ensure that alternative measures are in place to maintain data consistency. Dropping constraints should be a well-considered decision, executed with precision to avoid unintended consequences. Section 9. Disabling and enabling constraints, temporary control. Oracle Database offers granular control over constraints, allowing you to temporarily disable or enable them without permanently removing them. Imagine a castle with gates that can be closed and opened as needed, controlling access without altering the castle's structure. Disabling and enabling constraints provides this level of control, allowing you to manage data flow while maintaining the integrity of the underlying constraints. To disable a constraint, you use the alter table statement with the disable constraint clause, specifying the constraint name. Oracle will temporarily suspend the constraint's enforcement, allowing data operations that might otherwise violate the constraint. Enabling a constraint is equally straightforward, using the enable constraint clause to restore its enforcement. This temporary control over constraints is particularly useful during data migration or bulk loading operations, where temporarily disabling constraints can expedite the process. For instance, if you're loading a large data set into a table with foreign key constraints, disabling these constraints during the load can improve performance. However, it's crucial to remember that disabling constraints should be a temporary measure, and constraints should be re-enabled promptly to restore data integrity enforcement. Disabling constraints for extended periods can leave your database vulnerable to data inconsistencies and should be avoided. Section 10. Best practices for constraint management. Mastering constraint management is essential for maintaining data integrity and ensuring the reliability of your Oracle database. By adhering to best practices, you can maximize the effectiveness of constraints, prevent data corruption, and streamline database administration. Just as a skilled blacksmith carefully crafts and maintains their tools, a proficient database administrator diligently manages constraints to ensure their optimal performance. One crucial best practice is to define constraints during the database design phase. By incorporating constraints early in the process, you establish a solid foundation for data integrity from the outset. This proactive approach prevents data inconsistencies from creeping in and ensures that your data model is robust and reliable. Another best practice is to use meaningful names for constraints. Descriptive constraint names enhance readability and make it easier to understand the purpose and scope of each constraint. Avoid generic names like FK_1 or CK_2 and opt for names that clearly indicate the constraint's function, such as order_customer_FK or product_price_CHK. Regularly review and audit your constraints to ensure they remain relevant and effective. As business rules evolve or database schemas change, constraints may need to be modified or dropped. By staying vigilant and proactively managing your constraints, you can prevent data integrity issues and maintain the accuracy and consistency of your data. Section 11. Conclusion. In the realm of Oracle Database, data integrity reigns supreme, ensuring that information remains accurate, consistent, and trustworthy. Constraints, the unsung heroes of data integrity, play a pivotal role in upholding these principles, acting as vigilant guardians against data corruption and enforcing the rules that maintain order within the database. From the fundamental primary key constraints that uniquely identify each record to the versatile check constraints that enforce complex business rules, Oracle offers a comprehensive suite of tools to maintain data integrity. By mastering the concepts of primary key, foreign key, unique, and check constraints, you gain the power to build robust, reliable, and trustworthy databases that serve as the bedrock of your organization's success. Understanding how to add, drop, disable, and enable constraints empowers you to fine-tune your data model, adapting it to evolving business requirements while safeguarding data integrity. Adhering to best practices for constraint management, such as defining constraints during the design phase, using meaningful names, and regularly reviewing and auditing constraints, ensures that your database remains a bastion of data integrity. By embracing these principles, you elevate your database administration skills, ensuring that your data assets remain accurate, consistent, and reliable. As you embark on your journey into the world of Oracle Database, remember that data integrity is paramount. Embrace constraints as your allies, wielding their power to fortify your databases against data corruption and uphold the sanctity of your information assets. With a firm grasp of constraints and a commitment to best practices, you'll navigate the complexities of database management with confidence, ensuring that your data remains a valuable and trustworthy asset for years to come.